Okay, so let's look on a very nice proof that shows us why unitary transformations, and by that you can conclude also on orthogonal transformation in the real space, but let's talk more generally on the complex space, so we'll talk about unitary transformations. So it will show us in a very simple way why unitary transformations preserves the inner product. As you can see, if I take the unitary transformation u, let's call this is the unitary transformation for us, and I do ux uy and do an inner product between them, you can see that I get exactly the inner product between x and y. In order to understand that, let's start with the definition for a unitary transformation, which is the complex conjugate or adjoint, more precisely, multiplied by the unitary transformation is the identity matrix. So we can take the adjoint. If we take the inner product between two vectors but multiply by the unitary transformation, we can take the adjoint. By definition, we get u adjoint u, which by definition equals I, so we set here I, and we get inner product between x and y. From that we can also understand that unitary transformation is an isometry because it preserves norms. It's the same idea with the inner product, where norm is defined by the inner product between the vector itself. So if we take the inner product between a vector itself with the same idea, with the same idea of how we showed this will also hold for norms. Therefore, a unit transformation is also an isometry, namely preserves norm. And what I mainly wanted to show that how unitary transformation and orthogonal transformation in the real space preserves the inner product between two vectors. Thank you very much, and that's it. And thanks for Gemini for writing it with LaTeX for me.